for joining. Today, we're going to be giving you a quick overview and demo on HashiCorp Terraform and Aviatrix. Just a quick highlight as far as what we're going to be focused on. Just running through the agenda, we're going to just introduce some of the panelists who will be presenting today. After that, we'll be giving you a quick overview on Terraform and kind of its capabilities. We'll be turning it over to the Aviatrix team after that to give an overview of what their platform can do. And then finally, we'll give a demo of both Terraform and Aviatrix. And so just for the panelists today, so Nick Popovich, I'm the Director of Sales at HashiCorp, working with the 16 Western states for public sector, specifically for state, local, and education. I'm also joined by James Nika, who is my Senior Solutions Engineer at HashiCorp based out of Maryland. Kyle Green is one of our partners who works for Prodigy Consulting as the Solutions Architect and CEO of Prodigy based out of Sacramento. And then last but not least is Fraser Lott, who's the Solutions Architect, who'll be providing an overview of Aviatrix and then also just giving a demo of Terraform and Aviatrix together. So kind of just getting into some of the challenges that we see at HashiCorp for provisioning a hybrid cloud infrastructure. A lot of organizations, they're typically on VMware today, and they're looking at moving to the cloud. I think when it comes to provisioning to the cloud, this is a typical workflow that we see when moving to the cloud. So usually business users, they're going to put a ticket in through the IT department, through their ITSM tool, which is a lot of times ServiceNow. That'll then flow to the operations team, which will then be sent out to the individual business units under the ops team, right? So if the ops team receives a ticket, they essentially will then hand it off to the server team, who's going to say, hey, for this digital resource, we're going to require, 4 virtual CPU of RAM, this amount of memory, this amount of disks, et cetera, et cetera. After the server team kind of assigns, whatever digital resources are needed for that, they're then going to pass it over to the security team. The security team is then going to say, hey, we're going to need Palo Alto Networks assigned to this with this type of protocol in place so that, it's going to be accessible by this specific group. So by and large, this process, this is, typically how we see organizations, doing this at the state level and also the city and county and even education. And I would say, when it comes to provisioning to a single cloud, let's just take AWS, for instance, that's great. But I think some of the challenges that we've seen is when you add in, hybrid clouds, so VMware or even, a multi-cloud infrastructure, right? So if you have GCP, if you have Azure, that's, using different tools to provision to the cloud is kind of the main part, which we focus on with Terraform. And then taking that a step further, so putting guardrails in place in your cloud infrastructure, right? So if it's, costing thresholds or governance and compliance limits, or even, baking in security to your entire environment, and then managing, from the ServiceNow portal to VMware to AWS in a single place, that's really what we focus on with HashiCorp Terraform. And so alternatively, a lot of organizations are looking at Terraform as that agnostic tool just to provision to a hybrid cloud environment for VMware, AWS, or even a multi-cloud environment, with GCP and Azure as well. And so, using the same analogy, if you have business users who are requesting a specific type of digital resource or a service, through an ITSM portal, that's still going to flow to the operations team. And so the ops team, instead of actually, going to each individual, server unit or even the security unit, what they're going to do is they're going to actually have specific preset modules by saying, hey, we're going to create a small, medium, large type of size for all future resources that need to be requested. So instead of pinging the individual teams, if it fits within the parameters of these different templates, we're automatically going to provision that specific resource with this type of server, with this type of security policy, with this type of networking policy, so that long term you have an automated workflow. So what we've seen, at the state level in a lot of cities, this process can take anywhere from 1 to 4 months. When you have something like infrastructure as code, which is what Terraform represents, The process goes from 4 months to about a couple of weeks, just based upon how automated you want the workflow to be. And then furthermore, if you want to apply guardrails and governance to kind of like this multi-cloud or hybrid cloud infrastructure, that's something that we use with something we call policy as code or Sentinel within Terraform. So policy as code, which James will kind of get into a little bit later, it allows you to set thresholds, whether it be compliance or the specific type of resources you want to use, or even financial types of thresholds, right? So if you're a university team and then you have a developer team that you want to set a threshold for $100 for all the developers in AWS, but then everyone else only gets a $50 limit for that same type of infrastructure in AWS, you can do that with something like policy as code, which sets those thresholds. Additionally, if you want to have compliance, right? So a lot of organizations that are faced with HIPAA, FIPS, NIST, a lot of their compliance codes. If you want to enforce that compliance, just the technology components of it, you can write that into the code so that all your infrastructure moving forward will have that compliance baked into it. But holistically, from the ServiceNow portal all the way through provisioning those resources in the cloud, in any cloud, right? That's really where Terraform comes into play. And so I'm going to turn it over to James Nika, and he's actually going to kind of give a more granular overview of what Terraform is and how it can help. So James, I will turn it over to you.
Thank you very much, Nick. So I want to go a little bit deeper into how Terraform actually delivers this value. What does the Terraform Enterprise capability provide to some of our customers and prospects? So the broad and big idea here is that the provisioning of infrastructure into the cloud at scale is a form of workflow. It's a workflow in which you imagine and make determinations about the type of infrastructure you'd like to stand up. You design that infrastructure, whether you're doing it through a GUI interface or whether you do it in a file, and then you want to realize that infrastructure in some way. You might do that manually, you might do that with a script or an Ansible playbook, or you might use a capability like Terraform Enterprise. So the way Terraform Enterprise is different is that it does a couple of things that solve for some of the big problems you encounter with that workflow. Some of those problems include the coordination problem, which is how do you get different teams to coordinate amongst themselves in such a way that they don't step over each other's toes or change or modify or destroy each other's infrastructure. How do you get those teams to work with standard components? How do you get them to all ensure that every provisioning action is consistent, it's reliable, it's replayable, and you can depend on the results that will come out of it? So that's what Terraform Enterprise solves for. And the way it does that is it provides you with an interface where you can, first of all, use an infrastructure as code configurator. This is a form of wizard within the Terraform Enterprise, where you can pick modules from a private module registry within the application. You bring the modules you'd like to composite together to build some infrastructure. And what that will do, as you see there in step 1 in Cyan, it will generate an infrastructure as code file, which you see in step 2. And the beauty of this infrastructure as code file is it is human readable, but it's also machine parsable. That means any person, any member of your development, operator teams, security teams can look at that file and get a sense for what it will be standing up for infrastructure. But Terraform Enterprise can also take it, translate that into a set of API calls against a cloud provider to actually stand up infrastructure. So that's what you see in step 3 there is once that infrastructure as code file with composited modules has been created and generated for you, you will be able to pass that into Terraform Enterprise. It will apply policies, which are also written as code within the Terraform Enterprise platform. These policies are typically things that you would want enforced automatically. And you want to, again, reduce the complexity, the overhead of having to have meetings around making sure that policy is being followed, looking at logs and doing log analysis. Why not just have software ensure that every provisioning action is consistent and meets policy? And I'll talk a little bit more about that Sentinel engine. Once it passes policy, the Terraform Enterprise engine, which is very much similar to the same open source product we all love and use today, will now make the API calls against a cloud provider like Amazon Web Services or Google or any other provider to actually stand up infrastructure. Next slide, please. So I want to touch a little bit more on this idea of compositing infrastructure. The basic idea is we're trying to move towards a world where we don't have to define every low-level component that is a part of our infrastructure. If we can modularize them, make them like Lego blocks, we essentially can put together the different modules that we would like to to put together, to composite, in order to build much larger configurations of infrastructure. And what is key is ensuring that these modules are standardized. We know how they perform. They are configured specifically for our organization. They are vetted by security. They are secured. And you also want to keep them available to all the different teams that might want access to them to build different kinds of infrastructure that they would like to stand up for their business needs. And these modules must all be wrapped with the same cloth of the policy as code to ensure you don't exceed cost, you don't provision during maintenance windows, to ensure everything that needs to be encrypted is encrypted, that you don't have openings in the infrastructure that make that infrastructure insecure. Next, please. So from the consumer's point of view, they would see different modules available in that registry. There might be modules specific to AWS, right? So an entire development stack, or perhaps a stack of modules only for setting up a read-only in-memory database. For those who are VMware inclined within the organization, they might have their own set of modules, really for standing up their own virtual machines, configured specifically for their environment. Or you might do it functionally and say developers would like to have a set of modules that meet their needs for testing various pieces of code, maybe for deploying serverless capabilities, whatever it might be. Next slide. And all of this, again, is done in the context of compliance, security, and ensuring that there's visibility and knowledge of what is happening during every single provisioning action. Notice, if you see in this diagram here, from the left to the right, you have Terraform doing what it always does well, which is to plan infrastructure and then ultimately apply it. And so what you get that is a true benefit and in high demand from our prospects and customers is this ability to insert in between the actual standing up of that infrastructure, the application of policy sets. These might be policy sets that look at the networking configuration of the infrastructure you're about to stand up. They might look at the memory and compute sizing of that infrastructure. It's grouped together in different policy sets so it can be applied throughout all your infrastructure or through parts of infrastructure. And that's what Sentinel is. It's a way of taking policies that are normally articulated in a document, in a meeting as directives from senior management, and taking them and reifying them, making them actually pieces of code that can be applied as part of that infrastructure provisioning process. And the result and the huge benefits that come out of this include a reduced risk, right? Because now you can be confident that this action is being taken continuously and with every single action. You don't spend time having meetings or water cooler discussions or formal ticket processes. to double check and ensure that that people are complying with this requirement, or even overspending on infrastructure. So you have a reduced cost benefit as well there. And then finally, you take the human out of the loop. That usually will increase productivity by allowing much faster infrastructure provisioning. And so at this point, I think I'd like to hand over to, Fraser, to perhaps give us a short demo, or to have the Aviatrix team talk a little bit about their capabilities.
Cool, thanks, James. Yep, let me kick off a couple slides here. I know nobody wants to see any more slides, but I just want to do a quick overview on our platform, and then we'll go right to the good stuff. So Aviatrix, again, we'll just jump right into the important pieces here that everybody wants to see. The Aviatrix platform is basically built on a few things. One, the main component being the Aviatrix controller. Something important to highlight here, and you'll see in the little gray text there on the side. This is a device that you own, right? You spin this up in your environment. This is not a SaaS platform. So it is a crucial part of your infrastructure, and you manage it. And you can think of it as the brains of the operation, right? You take what you want to happen, you tell the controller what to do, and the controller provisions it for you. In conjunction with that, we also have CoPilot, which is the visibility component of it. Again, a separate instance that you own and manage, that's basically going to pull information from the available, pieces that Aviatrix provides you. The key part of that, and really what kind of pulls everything together, is these gateways. Now, we certainly work with a lot of cloud native constructs. We're very cloud aware. We're cloud first. This is not a refactored on-prem design. This is built for the cloud. And so ultimately, all the things we do are designed to optimize and augment some of the deficiencies the cloud have in terms of connectivity and security. So with that, we also talk directly to cloud native constructs, but also to some of the bigger third parties in security that you might recognize down there, Palo Alto, Checkpoint. So when it comes time to meet some of those compliance standards, and you need to take your security up a notch, and you don't want to do something like backhaul traffic down into a data center for cloud compliance, we ease the provisioning and service insertion for those devices. So let's jump into kind of some of our use cases here. And again, just to reiterate the reason we're talking about this, all of this stuff that you see here, everything that is being built can be done through Terraform, right? So this is completely compliant with infrastructure as code, and keeping everything in that pattern. So let's look at a single cloud use case here. We've got AWS, we've got one region, we've got a couple of VPCs and a transit and connectivity, most likely direct connect down to your data center. And you can kind of see how that ties together using Aviatrix as a transit there, essentially a connectivity piece for your on-prem connectivity. And then we start connecting other regions, right? So now I've got a second region, and I want to tie those in together. Doing that with some of the cloud native constructs, whether that's AWS, Azure, isn't always clean and friendly. And that's where tying this together with Aviatrix becomes very simple and clean. But really the consistent thing you'll see here as we blow this out is that it's repeatable, right? This is the same design. I'm going to pull in Azure, and I'm going to pull in GCP. So I don't need to go reinvent the wheel as this starts to expand. Some of the common reasons people end up getting thrown into this boat, acquisitions, right? Your company suddenly acquires a new division, and they've been using Azure, and now I need to ramp up my Azure skills, but I don't necessarily have the time to devote to that. You can extend that to any cloud, and you can see where this is going. Basically, I need a way to take what I've already learned from AWS and transplant that onto those other clouds, and that's where Aviatrix really simplifies it. So what we have here, what we just highlighted there, is what we call high performance encryption. So that's a big component of cloud connectivity. Oftentimes you'll hear the number 1.25 gigs thrown around. It's a, you know, kind of the limit that the clouds will give you on their native IPsec connectivity. So we've got a proprietary technology that actually allows you to go past that using our gateways to build that connection. So theoretically, in some of these situations, you're looking at 30, 40 gigs of throughput where you were typically limited to, you know, 1.25 in some of those scenarios. Layer on segmentation with that. So it's nice, pretty colors there, but the idea is I've got different business units, prod, dev, QA, you know, staging, testing, whatever you want to call it. I don't necessarily want all those to talk. I want everything to be connected, but I want to be able to control what's allowed to talk. And that's really where segmentation comes into this. We've layered this global concept of building out different divisions and being able to decide who's allowed to talk to who very simply. You know, this isn't setting up a bunch of ACLs or security groups or managing a bunch of policy. It's a very simple, you know, just slide and click approach to dividing that up. And then this piece, throwing in firewalls, again, making that very simple, keeping it in the cloud, not having to backhaul traffic, putting it in line without having to do some of the things that firewalls typically require you to do in the cloud, like IPsec. So we allow the firewall to just do what it's doing best, just firewalling. And then throw in CoPilot. So I've now got my gateways deployed. I've got all these pieces out there. I've got API calls happening. I want to see where that traffic's going. CoPilot pulls it all together. So you're basically allowing yourself to grab all the net flow, all the syslog from all those components, pull it into one place, troubleshoot, view, take a look at what's going on in your topology, everything in one place, single pane of glass. And then throw in some more connectivity with user VPN and egress and ingress, and you kind of get a whole picture here. So I'm just going to show this one real quick, and then we'll jump into the goods. This is kind of just a more detailed view of what you just saw, and you can kind of see how, again, everything pulls in together. You've got direct connect over here on the left, tying into an edge VPC, and again, consistency across the board there on those designs. Firewalls in the edge VPC. I've got a hub and spoke model here. There's a couple, you know, scenarios here. There's VNet, native VNet peering in Azure, something we can do. You've got an example of MuleSoft over there in terms of third-party connectivity. So really, when you think of connectivity, when you think of injecting security, this is where Aviatrix really comes into play. So I will cut that, and we will jump over to the Terraform part of it. So what I've got here, I've got a Terraform Cloud account. And what I've built this workspace off is this GitHub repo over here. So the nice thing about this is without even knowing what I'm doing, I'm able to trigger a run off of any changes I make in my repo here. So I've already got this dialed in. It's a very basic flat file that's building a few things here, and you'll kind of, this is basically just pulled directly from our docs, which are pretty well established. But what I'm going to do here is just build one of our transits, a spoke, attach that spoke, and also attach my transit to a VGW, which is essentially going to be simulating like a connection to a third party or making a connection over a direct connect. So if you want to picture it, you can think of something like this. Now, this is an example using GRE, which we do as well, but I'm going to do mine with IPsec. But this is exactly what it's going to be building. So again, you can kick this off manually, or if you're using like a pipeline approach, someone checks in a change, it gets pulled in, and that will kick off a run over here on the Terraform side. So I'm just going to kick this off manually, and while this is going, I'll go through some of the other components of Aviatrix. But you can see how simple this is. It's going to go ahead and do a Terraform plan. If you've ever done this with the command line, you'll be familiar with what the output is here. It's going to tell me what it's going to do. Looks good. I'm going to confirm, and we'll get that going. So we'll check in on this in a bit. But let me show you kind of the interface here. So when you're actually in the UI, we have a nice simple workflow design. So if you do decide, some things are worth, clicking to build, this is where we go. So the controller gives you a central place where everything is visible, right? So all of my accounts get pulled into one place. I've got multiple AWS accounts, multiple Azure accounts, GCP, all thrown into one place. So I don't need to deploy controllers all over the place. It's just one simple point to do all this. Once I've got my accounts onboarded, everything follows a real nice, clean workflow design. So essentially what I'm doing with that Terraform script is exactly what's being built here, right? Building a gateway, enabling HA, and building a connection to a third party, which is essentially this VGW link that we're building. So it's basically paint by numbers for a lot of this. And again, that's the same thing you're going to be doing in AWS as Azure, GCP. It all works the same way. Throwing on a few spokes is as simple as just going down to step 4, step 5, and step 6. So it's very simple. When you talk about segmentation, again, this is what I was talking about before, enabling segmentation and allowing those policies before it was delineated by colors. But again, you can build this out as business units. So QA, you can see very clearly, is allowed to talk to dev, allowed to talk to staging, but not connected to prod. About as simple as it gets. And once you've got all those tied in, I get a nice list of how everything's put together. Now, again, you can take this up a notch. We also have this FireNet concept. That's what we're talking about with, inserting firewalls into the mix. And I'll step back a little bit to kind of show you how simple that is as well. So when you do have a need to place firewalls in the cloud, provisioning them is a challenge. Again, every cloud kind of does it differently. They kind of all have their own best practices of how it should be done, where it should be put. So we've definitely simplified that. But once you get everything in place, you see we've got all these pre-built designs here. So, pay as you go, BYOL with Palo Alto, Checkpoint, Fortinet. And what this will do is it'll actually provision the whole firewall, place the interfaces where they need to be, so you don't have to worry about doing that manually or scripting that up by yourself. So once I've got those firewalls in place, I've got my spokes attached, I get this nice simple policy workflow. And what this allows me to do is do the same thing as with the segmentation. I can decide which spokes, which third-party connections, which peerings, anything that's terminating on that transit, I can decide whether or not it needs to go through a firewall before it can communicate with the rest of the world. So for example, here, I've got a peering to my Azure in central US, and I'm saying anytime Azure is trying to talk to my Oregon transit, it needs to go through a firewall first. I've got an EKS spoke attached to the transit in Oregon. All the traffic to and from that EKS spoke needs to go through a firewall first. Site to cloud, that's our terminology for a third party. It's like an IPsec tunnel. So here I'm not inspecting it. Very straightforward. So once you get that all in place, I've got my connectivity, I've got my peerings, I've got my connections to third parties, I've got firewalls in place. Now I want to see how this all ties together, and I want to see how everything's working. So I can jump over here to CoPilot, our visibility piece, and we'll take a look at what we've got here. All right, let's check in on that Terraform. Okay, still working on it. So first things first with CoPilot, we've got a topology view. All of this stuff is down right now. I wanted to kind of bring up the new transit that I'm building on the side so you guys can see the difference here. But you'll see this is the topology that I've built out with my controller. And every piece here is tied together, and you can kind of see how these links are all pulled in here. But what you're seeing here is all these clusters of my different transits. So I can zoom in, for example, on that Oregon transit that we were just looking at, and I can open this up and you can see the actual components of it. One of the nice things about this is I can filter. So if, for example, I just want to look at what I'm doing in Azure, and let's keep everything else out, flip that filter on, and it's just going to zoom in on the goods, right? I don't need to wade through all the other stuff to get there. And again, I can look through directly into this and open this cluster up, and you can see what that's made of. One thing that comes with CoPilot is this new feature we call topology replay. And what you can do with this, think of this as like a version control of your network, right? I can see everything that's changed in terms of status and any infrastructure that's been updated. So what you actually see here is that Terraform that I kicked off, this is actually happening right now. So you're seeing live what's being built. So for example, if I've got a scenario where something was working yesterday, it's not working today, fingers are starting to get pointed, they always come to the network team, this would be the first place I go. Did anything change, right? Did somebody tear something down? What's the status look like? Did anything that was green yesterday is now red? This is where you're going to find it. The idea being you want to get right to the pinpoint, the problem directly without hunting around and running a bunch of pings to find out what's going on. So pretty straightforward, but very powerful. You can see it keeps a long list of all the things that have happened in my environment. If tunnels go down, gateways go down, if new peerings are torn down, everything's here. So Flow IQ is the next part of this. And I'll blow this out so we get a little bit more data here to make this a little more interesting. But what this essentially is pulling net flow from all of our gateways. So they are the next hops for my global network, right? They have a unique ability to view all that traffic and tell you all the connections that are happening, whether it's egress, east-west traffic, ingress, it all will inevitably hit one of these gateways. So we'll let this catch up here. And you see I've got a ton of data in here. And the nice thing about this, again, like the topology view, this is all filterable. So if I just want to, get to the good stuff, I can just click on one of these and it'll automatically apply a filter on it. Now you can also do this with tags. So I've already created a tag, but imagine, going back to that Azure example that I showed before, if I put a tag on my Azure instances, I can just click on Azure here as an example, and it'll automatically apply a filter accordingly. So we'll scrap that. But with that, you can go through, and we have other data that's available here. I'm going to clear this filter so we can get everything, and you can get a nice baseline of your network. This is weak trends of my network. If there's any unusual spikes, it'll be very apparent here that something's going on. So nice for establishing a baseline. Geolocation, pretty straightforward. A nice heat map of where everything's coming from and going. Again, you can filter on this as well, but this is just a nice snapshot of everything. Flows is just more of a diagram-based look at how everything's talking. I can clearly just see what's happening across these links. And then records is just a text format of everything that's been going across. So if you need to export this to a CSV and run some analysis on your network, bam, it's right there. So performance is basically pulling syslog from those gateways, right? And the useful bit here is that I can take a look at anything that might potentially be causing a problem in my network. So these are the new gateways I'm spinning up right now. And for example, you can see, some things you might be used to in troubleshooting or just, basic diagnostics. And we're able to pull those directly from those gateways. A cloud routes is really where this all starts to come together. One of the big problems with working with cloud consoles is that they don't necessarily make the information available in one place. Finding routes in AWS and Azure is usually involving multiple tabs, jumping around, trying to remember where you were last. So we've tried to put that all in one place. So there's a couple components to this. Gateway routes, pretty straightforward. All these gateways are running on software-defined networking. They all have their own route tables. And so everything you see in here is what they know, right? So I'm able to look at metrics, next hops, you know, how everything's tied together in one place. Take that up a step, and now I've got VPC and VNet routes. And you can start to see how handy this is. This is all my global subnet routes, Azure, AWS, GCP. I can go into any of these, and I can take a look at exactly what's, you know, designated as a next hop here. Right, so very straightforward. Something to notice here, we program in RFC 1918 routes. Just for anybody that's wondering how this whole thing works. Next level, site to cloud. This is our IPsec. These are all down, but you can see very clearly there's a status there, and I can see what's going on. Let's see what's going on with this. Okay. And then BGP, pretty straightforward. All right, so notifications. This is essentially, this ties into your knock concept, right? If I don't want people having to constantly press refresh to view what's going on with the network, I want to be notified, you know, proactively. So we're able to actually configure alerts on here. So what you can do is you can tie this into email. You can do, you know, Slack notifications, web, anything that's able to ingest a webhook can pull from here. And one thing to notice, these are self-remediating. So if a tunnel drops, but it does fix itself, this will close itself. So you're not, you know, chasing ghosts, trying to figure out what's going on. So App IQ really ties everything together here. And I'll run a quick sample here. So let's say I'm trying to run an SSH from a couple devices across my network. It's not connecting, and I start using my old bag of tricks, trace routes, pings, not getting much information out of that, especially in the cloud. So I'm going to go over here and I'm going to run this App IQ connection here. So what this is going to show me is the exact route that this packet would take. It's going to show me any latency in the path. So you can see there what we're running. And it's going to show me any of the usual culprits that might cause a problem for this. So again, pulling all that syslog into one place. And then we get this. This is what we call flight path. So these are things that usually cause problems for connectivity in the cloud. ACLs, security groups, route tables. So this is actually a pass. That connection would have worked, but if you see a failure, you get a nice big red fail there. So pretty straightforward. You can imagine how many tabs you'd have to have open for this to all tie together. So let's check on this. It looks like my run completed here. I'm gonna go back to the controller and see what we've got. Okay, perfect. So I've essentially built this. So while I was talking that whole time, I've got a site to cloud tunnel up that's connected to a VGW. I've got 2 new spokes and 2 new transit gateways all tied together. You can see this is my new transit, and these are my new spokes that are tied to that transit. So that's kind of everything in a nutshell. I'm going to stop sharing for now. Do we have any questions? If there's anything in the Q&A, we can hit those now.
Thanks, Fraser. Hey, I think at this point, Kyle Green, do you want to give a quick overview just as far as like what Prodigy Consulting is and kind of like, how you play in the DevOps world? Because I think for those of you who are kind of newer to the DevOps world, having a good solutions integrator, people who know these tool sets as you're transitioning to a native cloud world, that's something that Kyle and his company does. But Kyle, we'll turn it over to you for a quick overview, if that's okay.
Yeah, sure. Thanks, Nick. Let me throw this up here on my screen. Can you guys see my screen and can you hear me okay?
We cannot see your screen yet.
Okay. Yeah, you should be able to see it now.
Perfect.
Cool. Yeah, so I'm super happy that we were invited to join you guys today. Aviatrix has really got something that's special to the market, and that's something that we've found as a company working primarily in the public cloud space, in consulting and professional services, that a lot of our customers, we've seen it all, right? We've seen people trying to stay cloud native. We've seen people trying to go the route of third-party network equipment, virtual network firewalls, and things. But at some point, it's almost inevitable. Various business groups, have their own needs, and those needs often lead to multi-cloud deployments. And that's where things, I don't want to say start to unravel, but they become much more challenging. And Aviatrix has something special that can vastly reduce that complexity. And allow your teams to focus more on, building things that impact the business. Like Nick said, my name's Kyle Green, co-founder and architect at Prodigy Consulting. We're based out of Sacramento, California, but we work with customers in various places across the U.S. Our bread and butter is public cloud implementations, application modernization, migrations. But I'd say that one of our specialties and mainstays has been that upfront sort of architecture and the foundational elements around deploying landing zones and architecting public and multi-cloud virtual data centers. So these conversations are ones that we have very frequently, and yeah, we've also we're the organizer of the Sacramento Azure User Group Forum. We're big fans of HashiCorp and Terraform. Anybody that's deployed any sizable workload in AWS or Azure or GCP knows that it's painstaking to use the UI, and it's entirely impossible to reproduce whatever it is that you did deploy. And so this day and age, infrastructure code is paramount. It's an absolute necessity. And HashiCorp and Terraform, and the fact that Aviatrix plugs right into that ecosystem is a big selling point to us and our customers that have realized the benefits behind infrastructure as code. So yeah, I'm happy to have been invited and enjoying the presentation. And yeah, I think we were on to the Q&A, but that's all I had for my portion.
Awesome. Thanks, Kyle. I think there was one question, which was just answered by Frazier. Frazier, did you want to bring that up or?
Yeah, I don't know. I don't think we have audio on the
Okay.
panel from the attendees, but it was something about Acacia, which I'm really not familiar with. So, but if we got anything else, we can stand by for a little bit.
Sure. Okay. if there's other questions, feel free to hit us up because we can stay on this for a little bit longer. But just a quick call to action. If you want to have a deeper dive into any of the technologies we went over today, either talk to Travis, Ryan, or myself, just to have a better understanding of what Terraform and Aviatrix can do for you. Additionally, Travis actually brought this up before the call, but both of our companies have free workshops. So if you want to get free hands-on training, that's something we can definitely propose for your specific organization, because I know a lot of this sounds great, but I think up until you've actually used it, you can't really see how practical a lot of these technologies are. So I'd strongly recommend either signing up for one of the corporate workshops that we host online, or even if for your specific organization, we could plan something together. But I would say as call to action, that should be pretty much it. So let's we just had another question in the chat.
Okay, looks like it was just a clarification on the Acacia. So.
Okay. All right. Well, if there are no more questions, we appreciate everyone hopping on. And thanks everyone for your time. We'll be chatting soon.